Welcome everybody to a Khan Academy tutorial. Today we're doing determine the domain of functions. This is going to be algebraically. We kind of already did the graph one if you want to check out how to determine the domain range from a graph. But now we're just talking about the domain. That is the possible x values of these algebraic functions. Possible x values. Okay, now there's two considerations. This is domain. There's two considerations we need to make when we're talking about the domain. The first, well, I guess the third one. The first is we're going to consider that the domain is all real numbers except when there's two conditions. The first condition is when we see that there's an x in the denominator. We know that x cannot have a certain value. We know that x cannot equal 0. Why? Well, that would create a situation where we would have undefined. So if we have a situation where we have x as a denominator, we need to be mindful that it's going to be all real numbers except for the values that make it undefined. Okay, so that's our first consideration. The second consideration, let me draw a line like this, like that. Okay. The second consideration is when we have a square root. Now, this is important because, again, it's going to be all real numbers except where x is a negative number. So if we have underneath the square root as a negative number, we can't have that. So instead of saying x can't be something, we're going to say x needs to be bigger than 0. So greater than or equal to 0. That would be a condition of the domain for anything with a square root. Again, just to reiterate, the number one, you can't have undefined. 2, you can't have negative square roots because we would have imaginary numbers. And we don't want to consider imaginary numbers for the domain because we're talking about real numbers. So our first one that we're talking about, our first problem is, what is the domain of f, where f of x equals x plus 1 squared? Okay, remember, our assumption is it's going to be all real numbers except in these circumstances. Okay, so we need to consider here that this is going to be all real numbers, and then we are going to look for an x in the denominator or square root of x. Notice how we don't have either one of these for x plus 1 quantity squared. We don't have square root, and we don't have 1 over x. We don't have x in the denominator. So this is going to be all real values of x. We're going to assume all real numbers unless those two conditions apply. I know I've been saying that a lot, but I'm just trying to get that through. That's going to be all real numbers for this guy. Next question. Okay, now remember, it erased, but we're talking about our two conditions. Number one, we're looking for denominators with x. And then we're looking for radicals with x. So we notice here that we have this guy, we have a square root, so we have an exception. It's going to be all reals except for where underneath the radical, okay, so this value, where it's negative. We don't want negative values here. So we don't want negative values. That will make it not true. Okay, so what do? How do we determine which values it can be? Well, if we want the values to be positive, this is what our domain is going to be. So our domain, we want positive values. So we want x plus 3 to be bigger than 0. So x plus 3, this is the number, this is the term underneath the radical. So we want that to be positive. If it's negative, it's no good. We don't want that. So to determine our domain, we're going to make it greater than or equal to 0. So we just need to solve for x. So we're going to subtract 3, and we get x needs to be greater than or equal to negative 3. Okay, so if we put a negative 3 there, if we put negative 3 plus 3 square root, this would be 0. That's true. That makes a true statement. But what happens if it's less than negative 3? So if we put a negative 4, we get negative 4 plus 3. We get square root of negative 1. Guess what? That's an imaginary number. That is no good. We can't have that situation. So it has to be negative 3 and bigger. So we're going to look for that. All real values. So we're looking at our choices here. Okay, not the first one. That's just negative 3. We're talking about all the values less than negative 3 that are no good. So we want all the values that are equal to or greater than negative 3. All real values of x such that x is greater than or equal to negative 3. There's a couple other ones there designed to trick you because we need it to be negative, so we're going to check this. There we go. Okay, here we go. We have another situation, another exception. This is our first exception where we have x in the denominator. Now, what do we have to have here? Well, we're going to assume all real numbers except what? Except when this is equal to 0. That's going to be an exception. We don't want it to equal 0. Okay, so we need to see what values are the exception. We're going to assume all real numbers except the values that make that equal to 0. So what we're going to do here is, this is what I like to do. I say x minus 7, and it can't be equal to 0. Okay, it's all real numbers except x cannot equal what? Well, we're going to add 7 to both sides first. And we get x cannot equal positive 7. Treat that not equal to just like the equal sign as you're solving. So we know that x cannot equal 7. All other numbers are fair game. Now, why can it not equal 7? What happens if we plug it in? We plug in 7 in the top, 7 in the bottom, okay? We get 7 over 0. That is undefined. That you can't have that situation for a domain. You can't have an undefined situation. Okay, so that's not part of our domain. That's not a function. So 7 cannot equal. Well, now what about negative 8? Does negative 8 work? Negative 8 does work because we get 7 over negative 15, or sorry, negative 8 over negative 15. That's a real number. Okay, what about positive 8? Positive 8, you'd get 8 over 1. That's a real number. That works. So it's just one value that doesn't work. So we're going to look at our choices here. All real values except what? Except 7. We can't have 7 be the case there. So anytime you have a denominator with x, it's just going to be one value, or maybe 2, that it can't equal. Otherwise, it's all real numbers. Okay, let's take a look at this situation. Do we have 1 over x? No, we do not. Okay, we don't have to worry about that. That's not the situation. What about square root of x? Anything with a square root? No, we do not. Okay, so guess what? It's all real values. Nothing to worry about there. I hope this clears it up in terms of the domain and just doing this algebraically. This is kind of a trouble spot for a lot of people, so make sure you rewatch this, pause it if you need to. But thank you so much for watching, and I'll see you next time.